My name is Nina Kraus. I'm going to talk about sound ingredients for brain health. I'm a professor at Northwestern University working in our Auditory Neuroscience lab, which we call Brain Bolts. So we like to think about what we put into our bodies, and in many ways, we are what we eat. I hope to be able to convince you that we also are what we hear. So if you think about the ingredients of a seen object, it has a texture, a size, a shape, a color, and it's very concrete. And we live in a materialistic world, one in which if things aren't blingy and obvious to us, we don't tend to pay that much attention to them. And sound is a little bit like that, because sound has just as many ingredients as Dr. Frank told us: pitch, timing, timbre, phase. And these ingredients are invisible, and many of the world's most powerful forces, like gravity, are invisible. But sound is a very, very powerful force in our lives. And it needs to be right. It needs to be good. This is all about sound quality. Okay, so what we're able to do is the currency of the nervous system is electricity. And if we can put sensors on the brain or on the scalp, we can pick up the electrical activity that happens in response to sound. Right now, as I'm talking to you, the neurons in your brain that respond to sound are producing electricity, and we can measure that. And if we play a speech or a musical sound, we can see how good a job your brain does at distinguishing all these different ingredients of sound. How does it process pitch, timing, harmonics? I like to use a mixing board analogy because the brain processes each of these ingredients using separate mechanisms so that we can really understand where strengths are in someone who is a musical expert or any kind of a sound expert, or if someone has a disorder that affects auditory processing in the brain, there are certain bottlenecks and certain strengths. And it is important to know and to understand them. And now we are able to measure how the brain processes these ingredients of sound with unprecedented precision. So getting back to food, we know that there are certain foods that are good for certain body systems, and there are other foods that are not especially good for certain body systems. Similarly, I want you to think about what we do very much influences sound processing in the brain. What we do influences how we are able to process the ingredients of sound, and our experience in sound shapes our brains. So if you are someone who plays a musical instrument and your voice counts as a musical instrument, sound processing can be enhanced. If you hear sound through a hearing aid or any number of wearable devices, certain ingredients are enhanced, and your brain also learns and gets shaped by those ingredients and how they make your brain experience sound. We live in a noisy world, and if we hear a lot of noise, and I'm not talking about noise that is loud enough to damage our hearing, but noise that is just of a moderate level that can also influence how our brain processes these important sound ingredients. And finally, making sense of sound. Sound processing in the brain is one of the most complex jobs that we ask our brains to do. The brain needs to process these sound signals, which are happening very, very fast, and it needs to be processing these sounds with microsecond precision. There are neurons that respond faster than neurons actually can fire. So sound processing is very complex and very detailed, and you can imagine that if you get hit in the head, one of the first things to get disrupted is this very complex and delicate machinery. So, musical experience. We know that making music can enhance sound processing in the brain. And we can see this throughout the lifespan. And this is in people who, they don't have to be professional musicians, but people who regularly play music. And importantly, it takes time to change the brain. So our lab has conducted a number of longitudinal studies, both in Chicago public schools and with the Harmony Project here in LA. And what we have discovered is that the fundamental changes, the automatic processing in the brain, doesn't change after 1 year of regular music making. At least we didn't see any changes, but it took 2 years. It was after 2 years that we started seeing these changes in the brain's response to sound. So importantly, language and music coincide. And one of the ways that they coincide is rhythm. Now, rhythm is very obvious in music. Everybody knows there's rhythm in music. But there is also rhythm in speech. And I'm going to illustrate that to you.
Mr. Walker?
I am extraordinarily busy, sir.
I just wanted to ask about the chocolate. The lifetime supply of chocolate for Charlie. Well, when does he get it?
He doesn't.
Why not?
Because he broke the rules.
What rules? We didn't see any rules, did we, Charlie?
Wrong, sir. Wrong.
Under Section 37B of the contract signed by him, it states quite clearly that all offers shall become null and void if, and you can read it for yourself in his photostatic copy, I, the undersigned, shall forfeit all rights, privileges, and licenses herein and herein contained, etc., etc., fax mentis incendium gloria culpum, etc., etc., memo bis punitor delicatum. It's all there, black and white, clear as crystal. You stole fizzy lifting drinks. You bumped into the ceiling, which now has to be washed and sterilized, so you get nothing. You lose. Good day, sir.
So there's rhythm in speech. And it turns out that children who are very good at, for example, tapping along to a beat, also have better language skills. And what is lovely is that we can see this in the brain's response to sound. That red curve is the brain's response to the rhythm of sound. And we can see that it is the synchronizers, the kids who in fact can synchronize to a beat, whose brains automatically follow those rhythms, and they have better language skills. We also know that people who have excellent rhythm skills are better at making sense of sound in noisy, complex environments. Because again, there are rhythms in speech that one needs to make sense of. Now, music is one of the best signals for the brain. The brain loves music because it is regular, it has some regularities, and yet it also has a lot of surprises, so it's an interesting signal. As opposed to noise that really doesn't mean very much in terms of the sound-to-meaning connections that the brain wants to make. So we do live in a noisy world, and these moderate-level sounds really do influence what happens to our brain's automatic ability to process sound. So, you know, the sound of a subway or of an air conditioner, these are considered safe from, they won't give you a hearing loss, but they will make your brain lose its precision of sound processing. And we know that the way in which the brain processes sound, again, as Dr. Frank mentioned, is that there are these beautiful curves, and they are arranged in an orderly and systematic way, kind of like a piano. And this happens throughout the brain. And animals that are reared with low-level noise have neurons and have nervous systems that have lost some of this beautiful tuning. So, as I said, sound processing in the brain is one of the most complex tasks that our brain needs to do, so that if we get hit in the head, this is really one of the very first things that we can see disrupted. And again, by measuring the brain's response to sound, we can get information about the impact of concussion at the acute stages as people are recovering, and also to look at the legacy of the long-term legacy. So the idea of music and medicine is an old one, but what is new is that music is now being used to address a number of brain injuries and medical disorders. And this is an encouraging time for science, because really for the first time, the National Institutes of Health have expressed an interest across their many institutes of funding research that helps us understand what it is that music does to us biologically, and what is the impact of musical experience and various diseases on the brain. So why is music so powerful? Well, making sense of sound engages many parts of our brain: our sensory, motor, our cognitive, and our reward systems. And music is a jackpot because it engages all of those systems. Now, with respect to cognition, I want to just show you something. Listen to a sentence. See if you can hear a sentence in this noise. Anybody here? Okay, now listen to, this is the actual sentence.
The juice of lemons makes fine punch.
Now you're going to hear the first sentence. So do you believe me? That what you know about sound influences how you hear it. So this is a test. I want you to raise your hand as quickly as you can every time you hear a tone, and then put it down. And do not, I repeat, do not raise your hand when you hear the siren. Those are pretty good. Always catch somebody. Okay, but importantly, people who actively engage in music making are better at learning what sounds to attend to and which sounds to ignore. And that's important, not just for music, but for all kinds of sounds in the world. So sensory motor, the way we move to music, the way we move together, synchronizes us and influences how we feel about each other and whether or not we feel like cooperating. I want to show you this video. Here are two babies that are, baby that is getting bounced in sync with an experimenter. Now, how is that baby going to feel about the experimenter? Is he going to want to help her?
Uh-oh. Oh, no. Uh-oh. There.
So here's the other baby. And this baby is being bounced out of sync. Is that going to affect how that baby feels?
Uh-oh.
Whether
Oh no. Oopsie.
so maybe we should get some of our heads of state to. Okay, so then there is the reward system. And we know that such a system exists. It's called the limbic system in the brain. And we also know that when we hear music that we like, as we anticipate the exciting part of a musical piece that we know, dopamine is released by the limbic system, by a particular part of the limbic system, just at that time. And dopamine, of course, very much affects our moods. There are other parts of the limbic system that release dopamine at the point at which the musical climax occurs. So we know that this neurochemical system in our reward system is being excited by music. We can use biology to inform hearing health. Imagine you have a hearing aid, and it's not working especially well anymore, and now you can measure the brain's response to that hearing aid and measure the brain's response to another hearing aid or to a different setting. And you can compare and see, again, how these different ingredients might be processed, better or worse. And this can inform, I think, as we look towards the future, we can think about the hearing aid fitting and the development of all kinds of hearing devices is being informed by the biology, by what we know about how the brain responds to these different ingredients of sound. So biologically, we are what we do. And what we do very much influences how well our brain can process sound ingredients. Music making is certainly a thing that we can do that will enhance sound processing in the brain. And this is an exciting time because we're really in a position to be able to harness neuroscience to inform hearing and brain health. I invite you to visit our website to learn more about some of the work, but in particular, this advocacy link has the information about the influence of music and education on brain health, all in one place. So now, we're going to hear some brain blues. What is going to happen is that we will both hear the brain's response, how the brain responds to music, and we will be able to see that brain response. Now, how is that even possible? Imagine you have an instrument and it is producing sound, and that sound is being picked up by a microphone, and the job of the microphone is to transform the sound wave into electricity that then a speaker can play. Now, this little guy can listen to the sound coming out of the speaker, and his brain transforms the sound wave into the currency of the nervous system, which is electricity, and we can measure the brain's response, and we can play it out through a speaker. Now, notice that the sound wave and the brain wave physically resemble each other, and here is the sound wave, here is the brain wave. This is my favorite. Okay, so what is going to happen next is on this keyboard here, we have the response of the brain to every single note on this keyboard. And instead of listening to me, you are going to have the pleasure of listening to Danny Green who is going to play this brain, and his trio is going to improvise upon it. You see it? We don't see it. Danny Green. Danny Green and the brain.
Thank you very much. Thank you. There we go. Thank you very much. That was my first time playing the brain. Hopefully not the last.